The purpose of this video is to illustrate how Docker can be used to get a container up and running. What you need to do is you need to create a directory in which to compose the image. So I have actually already created a directory called devel stuff, so you can create your own directory, whatever name you want. I've also put a couple files in here. These are files that I want to use in helping to configure the image. Hello.tar is actually dirt simple. It just contains a directory, and that directory contains a file. And the reason I have that is I just want to illustrate how a tarball can be expanded on the image that we're building. I also have benny.cpp, another very simple program. I just want to copy this as an individual file onto the image and then compile it on the image to illustrate how all that works. So any files you need to build the image, go ahead and go in this directory, and then in this directory you want to create a Dockerfile, which is what Docker will use to build the image. We will start comments, begin with a pound sign just like in shell scripts, and then the first line is going to be from what are you going to build your image, what base image will you use to build on top of, and we will use this Ubuntu image, which is a bare bones almost empty image. The first thing we should do is we should update packages that are on this base image, and so this is going to look something like this. Now that would be the update. Now combined with the update, I want to go ahead and install packages, and the package I want to install is G++. Now potentially there could be several packages that I want to build, in which case for visibility it's nice to use this backslash to have this command split onto multiple lines. I'll go ahead and do that for G++, but that's the only package that I'm going to install at this time. I also have the -y here so that all questions are automatically answered, and that way it'll run as non-interactive. Of course, as implied by the word run, run means that this is a command that will be run on the image itself that's being built. Next, we are going to want to add a user, so we will run that command, the user add. We will give the name generic developer, and we want to create the home directory for that developer, and the login ID is developer. I also need to assign a password, so we can do that using the change password command, and what we can do is echo the name of the login ID and then the password that we want, and I'm just going to make the password identical to the login ID, and we pipe that into change password, and that will do that. Now I want to go ahead and take that tarball. Let me bring it up here real quick. Let's see, it was hello.tar. So as hello.tar contains the source directory, and that contains hello.cpp. What I actually want to do is I want to extract that in the developer's new home directory that had been created by the user add command. So I will run, or excuse me, the command I want to do specifically for extracting archives is called add. So to add an extracted archive to the system, and it's hello.tar is what I want to add, and then I just have to specify the directory in which I want that to expand, and I want that to expand in home developer. So that will, again, just to emphasize it, will extract the source directory and the contents of that directory, hello.cpp, inside of home developer. Now that is going to add that as root, so we're going to want to change the ownership of that to be owned by the developer, since that is his directory. So I will say change owner. I want the user and the group to both be developer, and I'll just do the entire home directory on down, so that'll catch that source directory. Next is the command copy, whereas add will extract entire archives onto the image. Copy will copy individual files. So I'm going to copy that benny.cpp over to the temp directory. And then I'm going to go ahead and run G++ on that. So I can run another command, G++, which will be on the system because of having added it up here with the apt-get install command. Incidentally, if you're unfamiliar with this notation, the and is going to use short circuit logic, so it will run this command first, and only if this command is successful will it then run this second command here. Alright, so we're running G++. We want to compile benny.cpp, and we will put that in temp, and we'll just call it Benny. Be the name of that executable. Finally is another keyword, cmd command. So run are commands that are run while building the image. Command is what is run when a container is started up from the image. So the command I'm going to run is, we just want to run a bash shell, and I always like the VI bindings, so I provide these extra arguments to this command as separate elements in this array here in the square braces. If for whatever reason you didn't want to do that, you could always cap it off just like that, but I will leave those in. And we can give it a try. Now what I want to do prior to having, I assume I don't have any typos in here, but I want to show what happens if I have got errors in here. So what I'll do is I will run, and I'll run a command that doesn't exist. So this will create an error in building our image. So assuming you have errors along the way, this will help debug it. So I'm going to go ahead and quit. The command is docker build. We can get a little help here and look at the various options that we have. What we're going to want to do is apply a tag, so I'm going to use this -t option. And let's get rid of the help. Build -t, I'm going to give this name, I'll call this develbox, or devel image maybe, or how about just devel. And then I want to build it from files that are in my current directory, including the Dockerfile being in the current directory. So we go ahead and run that, and you can see it's grabbing it from the Ubuntu image. If you did not already have that image on your machine, it would have actually obtained that. I do, so it went by step 1 quickly. The command wasn't found, so it ends. Now there are a couple outcomes for this having happened. If I do PS, docker PS shows me any images that are running. There are no images running, but if I do docker PS, not images, containers. Containers run from images. So using the C++ analogy, images are classes and containers are objects created from the classes. So if I look at all containers that were created, you'll note that in this aborted attempt here, it had a container that it was working with when things went south on us. So what I want to do is I want to go ahead and get rid of this bogus container. Now it's hard to read because these are bleeding on 2 lines, but if I highlight this, you'll note, actually let me highlight the headers. The very last thing is the name of the container, so that's what I'm interested in. So if I highlight this first item, we can see, you can tell that this was my failed one. It's at the top of the list, having run just a few seconds ago, and also you see that bogus command I had in here. So it's called clever write, and I want to go ahead and say Docker, I want to remove clever write. That gets rid of that. I can go ahead and do a ps-a again, and you can see it's no longer there. If I look at my images, I type Docker images, and that shows some images that I've had from previous uses of Docker, and we can see well, let's see, I don't see it actually. So we didn't get far enough in building the image for a half-built image to appear. So what I'm going to do, I want to redo this example, and let me put my broken command down there and see if I can get an image that is broken on here as well, so I can show you how to get rid of that. So let me say Docker build. I will call it devel, and from the current directory, here we go, building. Oops, what did I not get here? Did I forget to? Let's see if that did it. Docker images. No, it didn't. Alright, let's try again. I can't get this thing to break. Let me put this down here. And do the build again. There we go. Alright, that's what I was looking for. So you can get far enough into this build where it actually leaves an incomplete image, and the telltale sign is that it says tag none, repository none. What we want to do is remove the image. To remove an image, all you do is say Docker RMI, and you give the name of the image. So for instance, if I wanted to get rid of the my world image, I'd say Docker RMI for remove image my world, and that would remove it. Unfortunately, in order to remove this image, since it doesn't have a tag, I have to use the image ID. So I have to get a different kind of listing. I have to say Docker images no truncate, and now it gives me these big long image IDs, and I have to use that to remove the image. So that tag is convenient in that this is a short English word that we can use to remove an image. If we don't have that, and we have none, we have to resort to this big long key here. So we'll probably find it won't work, and I'll explain that in a minute, but I'll say Docker RMI, I paste that in, and when I try to remove the image, it says there's a conflict because there's a container that's using that image. So this gets back to what I did when I was starting out last time, which is if I do Docker PS, nothing's running, but if I do a PS-a to see all containers stopped and started, here I see this first image called admiring right, so I will get rid of that. Docker rm admiring right. In fact, I'm going to get rid of that one as well. Get rid of both of those images, or excuse me, both of those containers. Now, if I try to redo my RMI, now that I don't have any stopped containers associated with it, it goes ahead and it says deleted, deleted, deleted. If I do Docker RMI again, excuse me, Docker images again, you'll see that that unnamed image is no longer there. So, let me go back into the Dockerfile. Let me get rid of the command that breaks it. So all these commands should hopefully work now. And we will try our build command once again. Wait a little bit. And then it says it's successfully built. And there it is, the devel image. So now we can say Docker run. I want to run it in a terminal interactively. And there we go. There it is. Now, if I look at etc password, oops, I don't have them. Let me cat it. You can see there is a developer user, so if I wanted I could say su-developer, and now I'm logged in as that developer. ls, you can see there's the source directory, and if you recall, in the temp directory I had put Benny, and you see that it actually did compile Benny and create an executable which we can run. So that's all there is to configuring the image and running the container. Now if I type exit, if I say, excuse me, now I'm in root, now I exit out, now I've exited out of that image, or out of that container, excuse me. If I do a docker ps, there are no running containers, because once I exit out of that container, it stops. But if I do a docker ps -a, we can see that there is the container, excuse me, that's the image from which the container was created, but this is our container here, and it gives it a name. It's calling it, our container that it created was Compassionate Pike. And you can create as many containers as you want. If I run this command again, it'll create another container. Anyway, I can say docker exec, let's see, docker start. So one thing I need to do is I need to restart the container since it stopped, if I want to log back into the container. Now if I do a docker ps, you can see my container is started there. And for me to connect to the container, I can say docker, I want to exec a command. I want it to be an interactive session with a terminal and with standard in that I can interact with. And that is the container that I want to execute a command on, and what I want to execute is bin bash -ovi, and that logs me back in. I can exit out. There's my container still running. If I ever want to stop it, now my container is stopped, it isn't there, but of course the container still exists, and I can start that container up and continue to work with it at any point. Thank you.